Hello students, welcome to the next lecture on the probability and stat. Today we will discuss about the concept of confidence interval. Myself, Dr. Gar, working in the School of Mathematics, Thapar Institute. So what is the overview about the confidence intervals and why there is a need of this in the testing of hypothesis that we will discuss in detail. So first of all, when you are talking about the confidence interval, it is nothing but just the range of the estimates for the unknown parameters. So this unknown parameter, it can be the sample mean, it can be standard deviations, it can be the proportion or anything are there. So the target is on your choice. If you want to calculate the mean, then whatever the range of this estimator is called as the confidence interval. This confidence interval is used widely in the statistics for describing the amount of the uncertainty associated with the sample estimates of the population. Or in other words, you can say it are used to describe the uncertainty about the sampling methods. Whether you use any of the kind of the methods, whatever the uncertainty is there, you have to describe them. So in the nutshell, we can say the confidence interval is a range within which the most possible values would occur. So what are those possible values are there? We will see in this couple of slides. So whenever you are talking about the most possible values, it means they are talking about some intervals, that is the lower intervals and the upper values, and the target of these lower and upper intervals up to some level, and that level is called as the confidence level. We talk about the 90% confident. So if I say this value is there, we talk this as the lower and upper. So how much confident you are, say 90% or 95%. This is the meaning of the confidence intervals. What is the 90% confidence level means? This means that you would expect that 90% of the intervals what you have achieved, that will include the population parameter. Similarly, if you consider about the 95%, that means whatever you have obtained as a confidence intervals like lower and upper, then whatever the population parameter that will acquire in these intervals up to this 95% and so on. So what is the definition of this confidence interval is, if you have considered the random sample x and have some distribution functions with the unknown parameter theta, or you can say the statistical parameter theta, like say if you consider about the normal distribution, then it will be the mean and the variance are there. So we all know that if x follows the normal distribution and variance is this, then this is the population mean. So if you consider about the sample mean, then this sample mean is denoted by x bar. Based on this x bar, your target is to compute the value of mu, that is a statistical parameter, and all the other parameter which are not interested we denote it as a phi. Like in this case, this is my phi, this is my theta. Then we can define this confidence interval is nothing but this L and U, both are the function of the x, called as the random variable, such that their probability will be nothing but confidence level. What is the confidence level is, either you want to be achieved as a 90%, 95% and so on. So your target is to find the value of the L and U, that is a lower and upper bound, such that the probability would be achieved as per your confidence level. So if you achieve that much level for all the values of the theta and phi, then this L and U is called as the intervals and the corresponding value is called as confidence intervals. This gamma can also be defined in terms of the level of significance as 1 minus alpha, where alpha is usually as a 5% for this, and here is for the 10%, this is for the 5%, and this is for my 1% are my level of significance. These are my level of significance. Now our target is to find the value of the L and U in such a way that whenever you want to collect the x randomly, whether you want to collect x this, whether you want to collect x this and so on, whatever you achieve with the same probability of 1 minus alpha, that is nothing but gamma, and whenever you want to achieve this again and again, your actual value or called as the true value is lies in between this interval. So your target is to find the L and U very precisely, and this would be hold for all the values of the theta and phi. What are the various factors which are including the confidence interval? So there are the four factors which are there are the three major factors which are including them. The first one is the confidence level, whether you want to achieve as a 90%, 99% or the 95% are there. What are the sample size? If you consider as a sample size of say n is equal to 5, whether you consider the sample size of greater than 30 or whether the sample size is considered as less than 30. Third one is the variability in the sample. What is that? That is a variation in this samples are there. If you consider these 5 elements, whether the numbers are like 3, 7, 9, 10 or 12, or if you consider these 5 elements are there with respect to, say, here you can see 91, and you can see there have a large variation in it. There is a large variation in it, while in this case it has a small variation. So that's depending upon the variability in the sample. As clear that as long as you consider the high confidence level, that will give you the wider confidence interval. So it means if you consider as a 99% or 95 confidence, then it will be like of this. But if you consider as say 99% confidence, then it gives as a wider about that. Similarly for this up to say 90%. So as you consider the high the confidence level, the demand of this wider interval or confidence is also be the wider. Second is the sample size. If you consider as a sample size to be the large, then the confidence intervals are narrow. On the other hand, if you consider the sample size is small, then it will be wider are there. We will see in the couple of the examples in this last slides are there. The third thing is the variability. As we have greater variability in the sample, produce the wider confidence intervals, and vice versa for the less variability. So when you make an estimate of any of these statistics, make sure that there are the two terms in the probability and stat. One is the population and second term is called as the statistics are there. So when you consider about the population, we call as the mean is mu, and when you consider as a statistics, then the mean is denoted as x bar. So when you make an estimate in the statistics, either you consider as a test statistics or the summary statistics are there, or called as the point estimator. If you consider as this is my point estimator, or you can consider as the interval estimator, then there is always occurring an uncertainty about that, and the number which are based is totally depending upon the sample of the population which you are taken. Then this confidence interval is give you about the range, that whatever your expectations is fall in between this range. So make sure that whatever your expectation that may fall in between this L and U, whether you want to perform the experiment again or you want to resample this observation. For example, if you consider this N is 5 are there, and then you can find this lower limit as of this and upper limit as say 131.4, and if you consider as another of the 5 elements, and then your value of this theta must lies in between them. So that's why this confidence interval give you whether you want to perform the experiment again or the resampling with the same number of observations. What exactly the confidence interval will do? So remember, the confidence interval will give you this results are there, that is a mean plus minus of the variations. So that it give you the mean of your estimate plus minus variation in the estimations. That is what is the meaning of that? When you think about this is your estimation, so this means this is my mean plus of the variation, and this is my mean minus variation. This theta is nothing but my mean. So this gives you the range of the value that you expect to fall in between them, whether you want to redo your experiments with the certain level of the confidence. Again, remember that the confidence may be the 90%, 95% or the 99%. In statistics, you can say the confidence is another way to define the probability. Why? As we define that probability is of here is nothing but my 1 minus alpha, or called as the gamma. So this is a probability to describe this confidence R here. For example, if you want to construct the confidence interval up to the 95% levels, then what is the meaning of that? Whatever you got the probability in terms of this L and U, how much confident you are? You are confident 95 times out of the 100 that your estimates will fall in between these upper and the lower values. So that's the meaning of this 95 confidence level. Or you can say the confidence level gamma. This is the gamma is nothing but 1 minus alpha. Alpha is nothing but the level of significance. When you can use the confidence intervals are there? You can use the confidence interval at any of times. You know all these proportions. If you have the Z samples, for the last sample you all knows that this is my testing of the hypothesis are there. when you consider about the sample mean, if for the small samples or for the large sample. If you consider about the small sample, then you can consider as a t of test, which can be defined like of this, that is a x bar minus mu divided by s by root n. If you consider as a large sample, then it will be given as a z test, then the formula will be given as x bar minus mu divided by here. So based on this proportion, sample mean, or you can consider as the difference between the sample means or the variations are there. All these formulas in all these cases, and similarly for the chi-square, ANOVA and so on, you can use the confidence interval. But here the major important thing is that when you use these four formula or the chi-square are there like of this will either for the small sample or you can see for the large sample, it will give you only the point value are there. After the calculation you will get the single number. Similarly for here you will get a single number. So all these are the point estimates which will give you only about the point number, but they will not give you about the intervals are there. That means they does not give any information about the variation of the numbers. So it will give you only as a single number. So in order to get as a intervals or about the variation of the numbers, we will use the confidence intervals. How we can use that? So when we need to know to calculate the confidence interval, so our target is to find the value of this L and U. So for that there are the four things about that. The first thing you need to about the point estimate, that is the theta. So this theta, it can be the mean, sample mean, it can be the sample variance, it can be the correlations, it can be the proportions and so on. So anything you want to do, that is your point estimate, that is you need to construct the confidence intervals. So if you consider the population means corresponding to them, if you consider the population proportion, if you consider the confidence interval for the population variance or the standard deviation or the correlation coefficients. Another thing that we need is about the critical values. So all of you know that if there is a Z value, then we all know it's a 1.645 corresponding to the 5%. If you consider as a t-test, then it will be the t degree of freedom 9 about the 0.05 and so on. Then the sample standard deviation of the sample and the population size. These four parameters we need to calculate the confidence intervals about the Ln. How we can see about that? So once we once we know all these four factors, then we can easily calculate these confidence intervals. For example, when you consider about the large sample, that is whenever the sample size is greater than of the 30, then how you can find the confidence intervals? If you look about this testing of the hypothesis, these are my rejection portion and this is my accepted portion. Then your target is to find the value of this L and the U and call as the confidence interval. As we know that whenever the sample size is greater than 30, then we will always use the Z statistics as of here. Now based on this Z statistics, look at that, we need the four parameters. One is the point estimate, so that's the value of the point estimate. It will give you the point value. The second thing what we need is that we need the critical value, standard deviation and the sample size. So sample size we know that because whenever n is greater than 30 we know. Standard deviation we all know that. The only thing is the critical value, and we know that the critical value at the 1% is here, 5% is this, 10% is here. But the question arises is how you can check about the say 15% level of significance, what will be the confidence intervals. So how you can do? So if you go to the Google and write this standard normal distribution table, or you can see from any of the statistics table, if you want to look at that, if I consider as a 5%, so this shaded portion is my 5%, and we all know that this value is my center value and this portion is same. So this is my 2.5%, this value is my 2.5%. So look at that, if I consider this as here. Now if you consider about here, how you can say it's a 1.96. So what is that? This is my 0.05. What is the area corresponding to this? This is nothing but my 0.975. This is, what is that? This is remaining is my 95%. This is my 2.5%. So total is 97.5. So look about this table. What is the value? Where is the value of 0.975? You can see this is the value of the 0.97 corresponding to 1.9 and corresponding to 0.6. So it means the answer is my 1.9 plus of 0.06. So what is the answer is 1.96. Similarly, if you look about the 10%, that's the meaning of that. This portion is nothing but my 5% and 5%, and this is my 95. So if you look about that, where is the 95? This is 94. You can see this value lies in between them. You can see this value lies in between them. So that is 1.6, and in between them is my 0.045. So you can see the value is my 1.645. Similarly, if you look about this 2.59, so you can see 995 which are lies in here. You can see in this value 2.5 and up to here. So you can see this value here. So you can easily find from the statistics table. Now if you look about this 5% are there, so I can consider as a 95%. The value is my 1.96. So you can see this value is my minus 1.96 plus 1. And your target is to find what is the theta. In this case we're talking about the mean. Your theta will be mu. So your target is to find this value of mu. How you can do that? You can simply take a multiply from this side here. Now you can take x bar on the both side. You will get this as the here. So this is my lower, this is my upper, this is my population mean. So thence you can say the confidence interval is nothing but x plus minus 1.96 of here. So 95% is confidence interval by here. If you want to find the 99% confidence interval, what you can do, that is a 1%. You can change this 1.96 to be 2.576 and here, or in journal it can be written as z of alpha, where z alpha is the critical value of the z at alpha level of significance. So if you want to consider the 10% level of significance, then this value can be replaced by 1.645. On the other hand, if this, what is the sigma is? Sigma is nothing but my population standard deviation. But if population standard deviation is not given to you, then we can replace it with the help of sample standard deviation as small s. However, on the other hand, when you have considered the small samples like of this, then we all know that we will use as a t-test like of this x bar minus mu divided by s by root n. Then we can do again the similar part. We will try derive like of this. What is that? This is nothing but my critical value of the t tables at the alpha level of significance, where x bar is my sample mean and small s is my sample standard deviation divided by n minus 1. How you can find this value? If you look about the t tables, and you can see if you want to find this as a 0.05 for the two tail, this is my two tail, 0.05 is here. Degree of freedom is my 5. This 5 is called as the degree of freedom. Look at that, this is my 5, and the corresponding value is my 2.571 is here. Similarly for here, if it is a one tail, you can see about the one tail of 0.05 here, and the 5 degree of freedom is my 2.015. Now we can see about these 7 to 8 example to illustrate this concept. Now your first target is to identify that whether it's a small sample or the large sample. So your target is to find the confidence interval up to the 95% for the symbolic blood pressure. So look at this about that. So it means our target is to find only for here. You can see the value of the n is my here. Sample mean, that is the x bar. This is the standard deviation. So we can consider this as of smallest. Now you can see the value of the n is less than of the 30. So it means this is my small sample, and once it is a small sample, we can apply the t-test for the confidence intervals. So we can apply the t-test. So and hence our formula will be here. Why it's a 9? Because the degree of, since n is my 10, the degree of freedom is my 9, and my target is to find this value from the table. So you can go to the t table. Look at the level of significance is my 95%. You can see this is my 95%. So the level of significance is my 5%. You can see here degree of freedom is my 9. So you can see the value is my 2.2262. So you can replace this value here. X value is this. S value is here. You can substitute this. What is the meaning of this plus minus 10? Firstly, you can take it as a plus, and then you can take it as a negative. You can take this as of interval. So this is the mean of the population mean of the here. What is the meaning of that? That means if you consider this sample, you are 95% confident that the actual value, what is the actual value is 121.2, which are lies in between them of these intervals. Now you can see that 121 is very far away from this lower and upper bounds. Why? Because the margin of error is very high. This is the margin of error. You can see the margin of error is very large. Why? Because we have the n, which is a 10, which is of the small size r. If you consider a similar example, but here we can consider about the, again for this, you can see the difference in between them. Again, our target is to find the confidence interval for here. Now you can see the value of the n is greater than 30. That means this is for the large sample. Once it's a large sample, then we can apply the Z test. What is the Z test is my here. What is the value of the Z alpha at the 5% level? It is nothing but my 1.96. So I can substitute the value of the x bar here. I can take on the value of the Z is this, and I can substitute this value. And you can see this is my variation. You can see this is nothing but my mean plus minus variation. And you can see the variation is less in this case and here. And you can see the mean is 127.3 is near to them. And what is the meaning of that? That is a point estimator of the mean. 127 is, we are 95% is confident that this point estimator lies in between them. And you can see, as compared to the previous example, this 127.3 which are near to this interval. Also, you can see the range of this, that is a variation, is very small. Why? Because we are considered this as large sample. So as I discussed that if you have the large sample, then that is the sample size is large, then the variation is the small. Look at the another example are there. A random sample consists of the 30 samples, and is my 30, and on measuring their diameter, the mean diameter is my 91. So sample mean is my 91. This is sample standard deviation is my 8 mm, and your target is to find the 85% confidence interval. Now you can see the value of the n is my greater than equal to 30, so we have to apply the large sample. In order to apply the large sample, we need this value at how much confidence level is 85% confidence level, and the level of significance is my 15%. So once it is a 15%, it means this value is my 0.075, this value is my here, and this is my 85%, or you can say this is my 7.5. So what is the total portion of this? 85 plus 7, this is nothing but 92.5. That means 0.925. So you can look about the table, you can see here and find where is that 0.925 appears. So you can see 925 appears at here. This is not exactly, and this is not, that is in between them, that is a 1.4324. So you can see this value is 1.4, for this value is 1.9. What is the 0.925? This is my here. So you can see this value is 1.44, that is 1.44. So I can substitute this value as a 1.44. X bar is my here, S is this, N is my 30, and after the calculation you will get this as range. And you can verify that this point estimator is lies in between them. Hence the confidence levels are my this. Look at the another example. Now in this case you have to find this 90% confidence interval, and you can see the what is the value, how many numbers are there. These are my 10, which is less than of 30. It means it is a small sample. It means you have to apply the t-test. Once you are applying the t-test, the value is my 90%. So the alpha, that is the level of significance, is my 10%. What is that? You have to write here. What is that? N is my 10. So degree of freedom is my 9. So our target is to find this value at 10% level of significance. So look at the table. So I need firstly x bar. We can easily use this formula, sum divided by n of these numbers, and what is the s is n minus 1. You can easily do that. Sum of these numbers are my 80 upon 10 is 8, and what is that? This is 2 minus 8, 16 minus 8, 3 minus 8 up to 12 minus 8 square by here. After calculating you will get x bar and SR. Now only target is to find this value. How you can do that? You can look about this T table. The level of significance is my 0.10, degree of freedom is my 9, the value is my 1.833. You can substitute this value here. After the calculation you will get this confidence. Again you can see there is a wide range of this. Why? Because the sample size is very small. That's why the wide range are here. Look at the another example are there. So out of 100 of the people, so if you have the 100 peoples are there, you randomly chosen 46 as a men. So it means the sample is my 46, the mean is my 86, standard deviation is my 6.2. Then you can say the determine the selected men are tall enough or not. You can see in this case it is not given to you whether it's a 90% confidence, 95, 99 and so on. When nothing is given to you, then it means you have to take about 95% by default. So it means our target is to find the 95% of here. Since n is my 46, which is greater than of the 30, so then our target is to be here. What is the value of this alpha at 5% confidence level? That is nothing but 1.96. We all know that. So I can substitute all the values here. That is my 86 and so on. After the calculation, you will get this as intervals. And you can see 86. They have the less margin of error. You can see this is nothing but the margin of error. You can see the margin of error is my here, and this width is very small because the population size or the sample size is greater than here. So it means the out of the 100 of the peoples which are likely to be lies in between this here, if you consider as a 46 members of the men. Look at the last example are there. So if you consider as an experiment which are taken over 3532 participants, and out of them you consider as 1 to 9 are being treated as a hypertension. So what is the meaning of that? If you look about this statement, if you read this statement again very carefully, what is that? This is the out of, these numbers are out of this. It means this is not the mean, this is not the frequency. What is that? This is nothing but my proportion. This is the proportion. So what is the proportion? Is that this total, this n is my total number of the elements, and this is my here. So you can see this is my here, which is very large number. So the sample proportion is my this one. This is the sample proportion corresponding to the person of the hypertension. So once it is hypertension, so and this is greater than 30, so we have to apply the large sample of proportion. So once is the large sample of proportion, we all know that what is the formula for the large sample of proportion. This is my here. So it means what is that? This is the mean plus minus of variation, that means p plus minus of the z value of this proportion is my this denominator, p q by n r. So we apply the large sample of the proportion by using this formula instead of the mean and here. So now my target is to find the value of p dash, that will be here. The value of this at the 95% is, we all know that. What is the q? This is nothing but my 1 minus p. So we know p is my here. We can find the value of q as 1 minus of this. N is my 3532. That's the testing of the proportion. So now after the calculation, you again see the variation or the margin of error is very large, very small. Why? Because there is a large sample. And you can see this is my confidence intervals L and U, where this hypertension meditations peoples will lie between them. And you can see the margin is very small. So this is the way you can understand the concept of the confidence interval in a very simple manner. If you want to see some another videos like of how to write the null hypothesis, what is the type 1 and type 2 error, what is the Newman principles, what is the Fisher and so on, you can all find in the testing of hypothesis playlist, channel name Dr. Harishkar. I hope you can simply like, share and comment on this video with your friends. Best of luck students. Happy luck.